Assalamualaikum and hi, we are from Group 6. We're going to present our project report. The title is Lagrange Interpolation.
Hi, Assalamualaikum. My name is Nurul Husna binti Suadin. My metric number is CF190223. Today, I would like to present about our project introduction. So first, let's go to the background of study. This project describes about application of interpolation. We creating a problem statement, we must solve it by using our method of choice, which is Lagrange interpolation. Interpolation is a process of approximating a function of f(x). We must estimate the missing function value over the interval a,b. If we have only 2 points, which is x0 at x0 and x1 at x1, we must use Lagrange interpolating polynomial of degree 1 linear. With the formula as shown as below, the figure shows the straight line passing through 2 points. Meanwhile, if we have Lagrange interpolating polynomial that passes through 3 points, which is x0 f x0, x1 f x1, and x2 f x2, we must use Lagrange interpolating polynomial of degree 2 with formula as shown as below. The figure shows the polynomial that passes through 3 points. In general, Lagrange interpolating polynomial can be described as the sum of LIXFI. So next, let's move to the objective of study. Our main objective in this project is to investigate the rainfall data at Johor and to apply linear interpolation in solving the interpolation problem. Our problem statement. Our data was measured at Johor. So Johor was part of state of Malaysia, located at south of Malay Peninsula, with Malaysian borderland state of Pahang to the north and Malacca and Negeri Sembilan to the northwest. Johor has highly diverse tropical rainforests and an equatorial climates, with Mount Ophir being the highest point in Johor. This project required detailed rainfall data to calculate the surface runoff. In metropolitan areas, surface runoff is a major source of flooding and water contamination. If instead of allowing contaminated stormwater to infiltrate through soil during precipitation, surface runoff is built to transport polluted stormwater to storm drain. Majority of municipal storm sewer system release stormwater into stream, river, and other bodies of water without proper treatment, which can cause water contamination. So lastly, let's move to the case study. Annual precipitation gauge was measured for station in 2014 from January to July in entire Johor region. But somehow, in April 2014, the gauge was not collecting the data. But the data was collected as usual for the next month. So our case study is to find the approximate data for April 2014. That's all from me. Thank you.
Assalamualaikum. My name is Nurizati binti Zabidi, metric number CF190197. Today I will talk about literature review. It is divided into two, which is study on Lagrange interpolation and approximation of missing precipitation data and its needs in civil engineering. Study on Lagrange interpolation. Vijay Dahiya, 2014, presented the theoretical analysis of Lagrange interpolation formula in her paper. Power series, basic function, and quadratic interpolation employing basic function and cubic interpolation are used to assess the procedure. Hence, she found out that it works better for a function whose value will increase or remain constant with the independent variable. Next, Hakom Leftover Monica, 2017, state that theoretically, the basic Lagrange interpolation with numerous points Assalamualaikum. My name is Nurizati binti Zabidi, metric number CF190-7. Today I will talk about literature review. It is divided into two, which is study on Lagrange interpolation and approximation of missing precipitation data and its needs in civil engineering. Study on Lagrange interpolation. Vijay Dahiya, 2014, presented the theoretical analysis of Lagrange interpolation formula in her paper. Power series, basic function, and quadratic interpolation employing basic function and cubic interpolation are used to assess the procedure. Hence, she found out that it works better for a function whose value will increase or remain constant with the independent variable. Next, Hakom Leftover Monica, 2017, state that theoretically, the basic Lagrange interpolation with numerous points is of interest. Polynomials are fairly well-behaved and well-understood functions, and knowing that there exists a well-behaved function that runs through any finite number of points can be important when conducting a proof. Lagrange interpolation on real-world data set with multiple points, on the other hand, fail miserably. He suggests Lagrange interpolation can be beneficial for obtaining an approximation of the underlying function with few points supplied no more than roughly 4. In research from Zhao and Su, 1995, a finite differences approach is used to investigate Lagrange interpolation by polynomial in multiple variables. They establish a Newton-like interpolation formula as well as remainder formula, both in terms of finite differences. They show that a finite difference in which simplex supplying function admit an integral representation. Approximation of missing precipitation data and its need in civil engineering. Satari et al. State in their study rainfall has a crucial role in the hydrological cycle. Assessing reliable data is one of the first tasks in any hydrological or meteorological research. Precipitation data, on the other hand, is frequently incomplete. The presence of constant and accurate precipitation data in meteorological stations is required for accurate water resource planning and management. When precisely and consistently recording precipitation data in a certain time segment is not possible, it is required to estimate the missing precipitation data before using it in hydrological model. According to Norzaima et al., 2014, the importance of precipitation is identifying precipitation characteristic, occurrence and temporal and spatial variability, statistical modeling and forecasting of precipitation, and resolving the problems such as flood, drought, and landslide. In Malaysia, the number of rain gauge stations with complete record for a long duration is very scarce. Thus, the estimation of rainfall is needed if missing data happen at the principal rainfall station. Muhammad Qaida et al. 2021 presented in their paper that one of the most essential measurement variable in hydrological and environmental modeling is daily rainfall data. Rainfall data is crucial for determining water quality. Studies that use continuous data, on the other hand, are always plagued by the issue of missing values. Development of a system for obtaining an accurate estimate of rainfall is critical in hydrologic modeling. Rainfall data must be full, homogeneous, and acceptable quality in order to yield correct results in analysis. Next, FILA table. Fact, idea, learning, issue, action. The first round of data must be examined before beginning a project in a specific location. Idea, collect detailed rainfall data of the area. How to obtain rainfall data? Data from website. The rain gauge at one site in the catchment region is not working. Identify the missing data. What is the method to estimate missing rainfall data for learning issue and action? Reference from books about hydrology and mathematics. Select a suitable method. That's all from me. Thank you.
Hi, I'm Nurul Afifa. Now let me explain regarding to calculation. For the sample data taken is from daily projected rainfall for scenarios in Peninsular Malaysia. which is from January to July 2040. The data only focus on entire Johor regions. And for this table, it shows data from January to July, but there is a missing data happening in April 2040. So for the best method to find back the missing data in April is by using the quartile method of Lagrange. First, rearrange the dataset as the table shown. And the second, by using quartile method of Lagrange, use this formula and insert the following data. Estimation of the monthly data, precipitation data for April 2040 is interacting polynomial in terms of x. Hence, for the end results, it can be concluded the monthly precipitation for April is 249.3779 mm.
Hi, my name is Siti Shafawani. I will explain about discussion. We apply Lagrange quartile method to calculate the monthly precipitation data for April 2014 of Johor. Lagrange quartile method is identified as the most suitable method for 5 data. This method be able to prove the fundamental theorem on symmetric functions in the course of developing a more systematic approach to solving polynomial equations. By using Lagrange quartile method, we get the monthly precipitation in millimeter for April 2014 is 249.379 millimeter. The accuracy of measured precipitation data is important in hydrological community. Furthermore, precipitation result is important for weather forecasting and to monitor the status of the environment.
So let's continue to our project conclusion. In conclusion, we use Lagrange interpolation method. We employ quartile approximation for order, also known as Lagrange interpolating polynomial, which ranges over 5 points. The equation we use is P for x equals to L0 F0 plus L1 F1 plus L2 F2 plus L3 F3 plus L4 F4. The missing rainfall data for April 2014 is 249.379 mm. We found that the surface runoff can be calculated by monthly precipitation using detailed rainfall data. The data was an outcome from Johor from January to July 2014. The drainage system should be designed properly to avoid flooding. In this case study, we also learned the theory in the class and through the outsourced reference as well, such as through the internet and YouTube, then apply it in daily uses or in the real-world situation. All the objectives for this project have been achieved with the cooperation of members of the group. That's all from us. Thank you.